This is a documentary about a bird that most people would say they already know. The American robin is among the most abundant and widely observed birds in North America, a fixture of lawns and parks and morning soundscapes from Alaska to Guatemala. Familiarity, however, is not the same as understanding. Behind the orange breast and the cheerful song lies a natural history of surprising depth, a lineage stretching back tens of millions of years, a mastery of seasonal movement that crosses a continent, a reproductive strategy built for a world of persistent danger, a social intelligence that operates on scales both intimate and vast, and a relationship with human civilization that has shaped how an entire culture understands the turning of the year. What follows is an attempt to see this common bird clearly. Part 1. Origins. There is a bird so familiar across North America that its name has become synonymous with the season of spring itself. It arrives on lawns, tilts its head toward the soil, and pulls from the earth with a confidence that seems almost ancient. But the American robin carries within its very name a fundamental misunderstanding, one that stretches back centuries to the moment when European settlers first set foot on a continent they did not yet know, carrying with them the memories of birds they had left behind. The American robin, known to science as Turdus migratorius, belongs to the family Turdidae, the true thrushes. This is a vast and globally distributed family that includes some of the most celebrated songbirds in the world: the Eurasian blackbird, the song thrush, the hermit thrush, the varied thrush, and dozens of other species spread across every continent except Antarctica. The European robin, by contrast, belongs to an entirely different lineage. It is a member of the Old World flycatcher family, Musicapidae, a group with no close evolutionary relationship to the thrushes. The two birds share only one thing of biological relevance: a reddish-orange patch on the breast. When English settlers arrived in the New World and encountered this bold, conspicuous bird hopping across the ground with its warm chest catching the light, they reached instinctively into their memories and gave it the name they knew: the robin. It was a name born of homesickness and pattern recognition, rather than scientific rigor, and it has persisted for 4 centuries without correction. The Turdidae family itself has a lineage that stretches back tens of millions of years. The genus Turdus, to which the American robin belongs, is particularly ancient and species-rich, containing nearly 90 recognized species distributed across every major landmass. Most of the Turdus thrushes are found in the Americas and Africa, with a smaller cluster in Europe and Asia. The American robin is therefore part of a predominantly New World genus, but one that originated in Eurasia and spread through a single event across the Atlantic Ocean. Among the Turdus thrushes of the Americas, the American robin is one of the most successful and geographically widespread, but it is surrounded by close relatives that occupy overlapping ecological niches. The clay-colored thrush of Central America, recently elevated to the status of national bird of Costa Rica, is among its nearest relatives. The white-throated robin of South America and the rufous-backed robin of northwestern Mexico both sit within the same close cluster of species. The American robin is in many ways the northernmost expression of a great radiation of Turdus thrushes across the Western Hemisphere, a radiation that produced birds adapted to cloud forests, tropical lowlands, high-altitude scrub, and the open parklands and suburban lawns of temperate North America. The thrush body plan that defines all of these birds is one of remarkable versatility. A medium-length bill, strong and slightly curved, suited both for probing soft soil and for crushing berries. Powerful legs and feet designed for hopping across irregular surfaces and scratching through leaf litter, eyes positioned on the sides of the head to provide a wide field of vision, useful for detecting both food and approaching danger. A deep keel on the sternum anchoring the flight muscles of a bird capable of sustained long-distance travel. And in many species, including the American robin, a song of extraordinary complexity and beauty, produced by a specialized vocal organ called the syrinx, that has no equivalent in any other group of vertebrates. The spotted breast of juvenile American robins is among the clearest visible reminders of this thrush heritage. Young birds of almost all Turdus species emerge from the nest with spotted or streaked underparts, a pattern that provides camouflage in the dappled light of forest floors. It is only as the American robin matures that these spots are replaced by the solid orange-red of the adult breast, a transformation that happens gradually over the first months of life and is completed by the time the bird approaches its first breeding season. The scientific name Turdus migratorius, meaning roughly the migratory thrush, was assigned by the Swedish naturalist Carl Linnaeus in 1766 in the 12th edition of his landmark taxonomic work Systema Naturae. Linnaeus had access to specimens collected by naturalists traveling through North America, and he recognized immediately that this bird belonged to his genus Turdus, despite its superficial resemblance to the European robin. The species epithet he chose, migratorius, reflected one of the most conspicuous features of the bird's life history, its habit of moving across vast distances with the seasons, disappearing from northern landscapes as winter closes in, and returning again as the ice retreats. This migration had been observed and noted by indigenous peoples across the continent for thousands of years before Linnaeus gave the bird its Latin binomial, and it remained one of the defining characteristics that set the American robin apart from many of its relatives, which tended toward more sedentary lifestyles in the tropical and subtropical portions of the hemisphere. The American robin is currently classified within the order Passeriformes, which contains more than half of all known bird species, and is by far the most species-rich order in the class Aves. Within the passerines, it belongs to the superfamily Musicopoidea, a large grouping that includes both the true thrushes and the Old World flycatchers, united by molecular and anatomical evidence despite their apparent differences. The fact that the American robin and the European robin both fall within this same broad superfamily means they are distant cousins in the deepest sense, sharing a common ancestor perhaps 50 to 60 million years ago, but separated by enough evolutionary time and divergence to be unrecognizable as close relatives by any biological measure. What the name confusion does capture, even if accidentally, is something real about the ecology of both birds. Both the American robin and the European robin are generalists, adaptable, bold, comfortable in human-modified landscapes, drawn to open ground where soil invertebrates are accessible, and willing to nest in close proximity to buildings, gardens, and the persistent noise of human activity. The convergence in appearance and behavior between two unrelated birds separated by an ocean is a textbook example of parallel evolution, the independent development of similar traits in response to similar ecological pressures. Red breasts have evolved multiple times in birds, often in species that display prominently on open perches and use their coloration as a signal of territory and status. The orange-red of the American robin's breast serves the same communicative function as the red of the European robin, even though the two colors arose through entirely separate evolutionary pathways in lineages that had not shared a common ancestor since the age of the dinosaurs. Part 2. Habitats. The American robin is not a bird that asks much of its environment. Where there is ground soft enough to probe, trees sturdy enough to hold a nest, and enough open space to move efficiently between foraging patches, the robin will almost certainly be present. This tolerance for a wide range of conditions has allowed it to colonize an extraordinary breadth of habitats across North America, making it one of the most geographically widespread breeding birds on the continent and one of the most consistently visible birds in the lives of the millions of people who share its range. The breeding range of the American robin extends from the northern tree line of Alaska and Canada southward through the continental United States into the mountains of central Mexico, covering an area of roughly 9 million square kilometers, or approximately 3.5 million square miles. It is absent only from treeless Arctic tundra, open desert with no woody vegetation, and the dense interior of tropical lowland forests, where closed canopy and lack of open ground make foraging difficult. Virtually every other terrestrial landscape in between falls within its ecological tolerance. In the boreal forests of Canada and Alaska, robins nest in the open spruce and birch woodlands that fringe rivers and lake edges, arriving as the snow retreats to claim territories among the first migrant songbirds of the season. These northern populations tend to be among the most strongly migratory, pushing south into the United States and Central America as winter darkness and frozen soil make northern areas inhospitable. In the mixed deciduous forests of the eastern United States, robins are year-round residents or short-distance migrants, shifting their habits rather than their geography as berry crops replace earthworms in the winter diet. In the mountain forests of the Rockies and Sierra Nevada, they breed at elevations exceeding 3,000 meters, or roughly 10,000 feet, in conifer forests where snowfields may persist well into June. Suburban and urban environments represent perhaps the single most important habitat category for American robins across the present-day continent. Lawns are, from a robin's perspective, nearly ideal foraging habitat. Short grass that allows visual detection of movement below the surface, soil kept moist by irrigation and rain, and a consistent supply of earthworms concentrated near the surface. The widespread conversion of North American landscapes to low-density residential development over the past century has, paradoxically, benefited the robin enormously. Studies of robin densities across different land cover types consistently find the highest breeding concentrations in suburban and urban green spaces, parks, golf courses, and residential neighborhoods, rather than in primary forest. The relationship between robins and forest is more complex than their lawn-hopping suburban image might suggest. American robins are fundamentally birds of forest edge, drawn to the interface between open ground and tree cover. They nest in trees and tall shrubs that provide structural support and concealment, forage on open ground where soil invertebrates are accessible, and use forest interiors primarily for roosting and as a buffer against predators. In purely closed canopy forest with a dense shrub layer and deeply shaded floor, robins are generally absent or rare. They need the openness. Their visual foraging technique, which relies on detecting the subtle movement of a worm near the soil surface from several body lengths away, requires good light and unobstructed sight lines. Riparian corridors, the bands of vegetation that line rivers, streams, and lake shores, are consistently among the highest quality robin habitats across the continent. These linear strips of willow, alder, cottonwood, and other moisture-loving vegetation provide nesting sites and thick berry crops in late summer and autumn, while the moist soils of floodplains concentrate earthworms and other invertebrates near the surface even during dry periods. Robin densities in riparian corridors often exceed those of surrounding upland areas by factors of 3 or 4, and these corridors serve as important movement pathways during migration, funneling birds northward and southward along river systems that cut across otherwise unsuitable terrain. Migration in the American robin is a phenomenon of remarkable complexity and geographic scope. The species is a partial migrant, meaning that not all individuals migrate, and those that do migrate vary enormously in the distances they travel. Northern breeders from Alaska and the Canadian boreal zone may travel more than 5,000 kilometers, or over 3,000 miles, to reach their wintering grounds in the southern United States, Mexico, and Central America. Southern breeders in Texas or the Gulf Coast states may move only a few hundred kilometers, or less than 200 miles, or may not move at all. Some populations in coastal California and along the Pacific Northwest coast are essentially year-round residents, taking advantage of mild winters and persistent berry crops to avoid the energetic costs of migration entirely. The timing of robin migration is governed primarily by photoperiod, the changing day length that triggers hormonal shifts controlling migratory restlessness, and the accumulation of fat reserves for fuel. In spring, the northward migration of American robins begins as early as late January in the southern states and does not reach its full extent in northern Canada and Alaska until May or even early June. The arrival of robins is one of the most culturally observed phenological events in North American natural history, noted in diaries, letters, and natural history journals for centuries, and used as a reliable indicator of seasonal change by farmers, gardeners, and anyone who paid attention to the landscape around them. What makes robin migration particularly interesting from an ecological standpoint is its flexibility. Robins do not follow fixed routes in the way that some long-distance migrants do. They are capable of responding to local weather conditions, food availability, and temperature gradients in ways that make their movements more opportunistic than those of obligate migrants like Arctic terns or blackpoll warblers. In warm winters, robins may remain far north of their typical wintering range, concentrating in areas where persistent fruit crops, particularly on ornamental crabapples, hawthorns and hollies, provide enough calories to sustain them despite the cold. In severe winters, the same populations may push south rapidly, sometimes moving hundreds of kilometers in a matter of days in response to a single Arctic cold front. The wintering behavior of American robins represents a striking departure from the solitary territorial habits of the breeding season. Winter robins are intensely social, gathering in communal roosts that can number in the thousands or even tens of thousands of individuals. These roosts typically form in dense evergreen vegetation, particularly in thickets of holly, cedar, or hemlock, where the thick foliage provides insulation against wind and cold. Birds may travel up to 25 kilometers, or about 15 miles, from their daytime foraging areas to reach a roost site, following routes they appear to have learned from older birds. The roost serves multiple functions. It provides shared warmth through the collective body heat of densely packed birds. It offers safety in numbers against nocturnal predators like great horned owls, and it may function as an information center, where birds that have successfully located productive food patches are followed by others the following morning. The elevation of the robin's breeding range has expanded measurably over the past several decades in response to climate warming. In mountainous regions of the West, the tree line has crept upward as temperatures have risen, and robins have followed it, establishing breeding populations at elevations that were above their range boundary as recently as the mid-20th century. Simultaneously, the timing of spring arrival has shifted earlier across much of the range, with birds now arriving on average 1 to 2 weeks earlier in spring compared to records from the 1960s and 1970s. This phenological shift has been documented through both citizen science data and long-term research station records, and it places robins among the most clearly climate-responsive bird species in North America. Part 3. Food. The American robin is an opportunist, and its diet across the year is a testament to the advantages of ecological flexibility. No single food source defines it for long. The earthworm that dominates its spring and summer menus gives way to a fruit-heavy autumn and winter diet, and within each season the bird adjusts continuously to whatever the landscape offers. This flexibility is not merely behavioral, it is written into the bird's anatomy, its sensory systems, and the daily rhythms that govern how it moves through its territory. Earthworms are unquestionably the food most closely associated with the American robin in popular imagination, and for good reason. During the breeding season, earthworms make up the majority of the diet of adults, and crucially, an even higher proportion of the diet fed to nestlings. A large earthworm represents a dense package of protein, fat, and moisture, everything a growing chick requires, and a foraging adult can locate, extract, and deliver them efficiently enough to sustain both itself and a brood of hungry young. Studies of robin foraging behavior have documented adults making more than 100 foraging trips per day to a nest during peak chick-rearing periods, with earthworms comprising the bulk of each delivery. The mechanism by which robins locate earthworms has been the subject of genuine scientific debate. For decades, the common assumption was that the characteristic head-tilting posture of a foraging robin reflected the use of hearing. A bird cocking its head to bring one ear closer to the ground to detect the faint sounds of a worm moving through soil. This is an appealing explanation, and it is not entirely wrong. Robins are capable of detecting sounds, and their ears are sensitive to the low-frequency vibrations that soil disturbance produces. But careful experimental studies conducted in the latter half of the 20th century established that vision is the primary sense used in earthworm detection. A robin tilting its head is bringing one eye into the optimal position for downward-focused vision to scan a small patch of soil surface for the subtle movements and color contrasts that indicate a worm near the surface. The eyes of the American robin, like those of most birds, contain a far higher density of photoreceptors than human eyes, and they are sensitive to a broader range of wavelengths, including portions of the ultraviolet spectrum. Earthworm casts, the small coils of soil that worms deposit on the surface, may be visible to robins as ultraviolet reflective patches, providing an additional cue that is invisible to human observers watching the same piece of ground. The combination of acute color vision, ultraviolet sensitivity, and precise depth perception makes the robin's eyes extraordinarily well suited to detecting the small surface disturbances that indicate accessible prey below. Once a worm is located, extraction requires both technique and strength. A robin will grasp the exposed portion of the worm in its bill and pull steadily, sometimes bracing its legs and leaning back against the worm's muscular resistance. Earthworms have small bristles called setae that anchor them in their burrows, and a worm can resist extraction forces many times its own body weight. If the pull is too sharp, the worm breaks. If it is too slow, the worm retreats deeper. Experienced adult robins have clearly developed a feel for the correct force and angle, and they extract intact worms with a success rate that young birds take weeks to match. Juveniles in their first weeks after leaving the nest can be watched attempting and failing repeatedly at worm extraction, pulling too hard and snapping the worm, or losing their grip on the wet muscular body and watching the prey vanish back into the soil. Beyond earthworms, the spring and summer invertebrate diet of the American robin is broadly diverse. Beetles and their larvae are consumed extensively, particularly ground beetles that can be found under logs and leaf litter. Caterpillars, especially early in the season, before the earthworm population fully activates, represent an important source of nutrition. Grasshoppers and crickets are taken in late summer and early autumn, as these insects reach peak abundance in open meadows and grasslands. Fly larvae, centipedes, millipedes, snails, and small spiders are all consumed opportunistically. Robins have even been observed catching and eating small fish from the edges of shallow streams, though this behavior is unusual enough to attract notice when documented. The transition to a fruit-based diet in late summer and autumn is not simply a response to the disappearance of invertebrate prey. Fruit is actively sought and eagerly consumed by robins throughout the year when it is available. And in many regions, robins begin switching heavily toward berry consumption well before the first frosts arrive. The digestive system of the American robin is adapted for rapid processing of fruit. The gut passage time for small berries can be as short as 20 to 40 minutes, far faster than the processing time for animal prey. This rapid throughput maximizes caloric extraction from energy-rich fruit while minimizing the weight carried by a flying bird. And it has the important side effect of depositing seeds at considerable distances from the parent plant, making robins one of the most significant seed dispersers in North American temperate ecosystems. The range of fruits consumed by American robins is extraordinary. Wild berries of all kinds are taken. The small, dark fruits of serviceberries, cherries, and chokecherries in summer. The red clusters of mountain ash and hawthorn in autumn. The persistent blue or black berries of juniper and Virginia creeper in winter. The brilliant red fruits of holly, bittersweet, and pokeweed when other sources are exhausted. In suburban and urban areas, ornamental plantings of crabapple, cotoneaster, firethorn, and multiflora rose provide winter food resources that sustain large robin populations through conditions that would otherwise force them further south. The berries of some ornamental plants remain on branches for months, gradually softening through repeated freeze-thaw cycles until their sugar content is high and their texture is easily digestible, and robins time their visits to these resources with apparent precision. The relationship between robins and fermented fruit is one of the more remarkable aspects of their winter food ecology. Berries that have remained on branches through multiple freezing and thawing cycles can undergo natural fermentation, with yeast breaking down sugars into ethanol. Robins consuming large quantities of these berries may accumulate blood alcohol levels sufficient to cause observable behavioral changes, unsteady walking, difficulty in flight, and apparent disorientation that can leave birds vulnerable to predation and window strikes. This phenomenon has been documented repeatedly in winter months across North America, with birds found unable to fly in the vicinity of heavy fruit crops, and it represents one of the more colorful unintended consequences of a flexible dietary strategy. Daily foraging patterns in the American robin follow a rhythm shaped by light and temperature. Feeding activity typically begins shortly after dawn, reaching a peak in early morning when earthworms are still near the surface, following the cool of the night. Activity decreases through the hottest part of the day, when earthworms retreat deeper into the soil and the energetic costs of foraging increase. A second foraging peak typically occurs in late afternoon before roost departure. During the breeding season, the daily energy demands of incubating eggs and raising young push foraging activity higher and shift its distribution, with females spending more time on the nest and males increasing their own foraging intensity to support the energetic costs of mate feeding and chick provisioning. Water is as important as food to the American robin, and the bird's preference for lawns and other moist soil habitats is not only about earthworm availability. Robins drink frequently, and they bathe with an enthusiasm that is conspicuous and seemingly genuine, splashing in bird baths, puddles, and shallow streams with a vigor that seems out of proportion to the practical requirements of feather maintenance. The bathing behavior serves to clean the feathers of parasites, dirt, and the residue of fruit consumption, and it is followed invariably by extended preening, during which the bird draws each flight feather through its bill to realign the microscopic barbules that give feathers their aerodynamic and insulating properties. Part 4. Predators. The American robin exists within a dense web of predatory relationships. From the moment an egg is laid to the final days of a bird that manages to survive into old age, predation is the constant pressure that shapes behavior, habitat choice, nest placement, alarm calling, and the timing of every daily activity. Understanding how robins live requires understanding what hunts them, and the list is long. Among aerial predators, the Cooper's hawk is perhaps the most consistently significant threat to adult robins across much of their range. This medium-sized accipiter is built specifically for the pursuit of medium-sized songbirds in forested and suburban habitats, with short, rounded wings for maneuverability among branches, a long tail for precise steering, and powerful talons adapted for gripping struggling prey. Cooper's hawks have expanded their range into suburban areas over the past several decades, following their prey base as robins and other large songbirds colonize these landscapes in increasing numbers. The relationship is so close that in some suburban areas, robin territory maps align almost exactly with areas of lower Cooper's hawk activity, suggesting that robins respond to the local distribution of this predator when choosing where to settle. The sharp-shinned hawk, a smaller relative of the Coopers, also takes robins with some regularity, particularly during migration, when both species move through the same stopover sites and robins may be less familiar with local escape routes. The larger accipiters, including the northern goshawk, occasionally take robins in forested regions, though the goshawk's preference for grouse-sized prey makes robins a secondary rather than primary prey item. Falcons present a different kind of aerial threat. The American kestrel is too small to reliably take adult robins, but the merlin, a compact and fast-flying falcon of open country and forest edge, is an effective robin predator during migration. The peregrine falcon, now recovered from the brink of extinction and increasingly common in urban areas, takes robins opportunistically in city environments where both species are regularly present. Owls represent the primary nocturnal threat. The great horned owl, the largest and most powerful owl species in North America, is capable of taking virtually any bird up to and including large waterfowl, and robins roosting in communal winter roosts are accessible targets when the roost site is located near good owl habitat. The barred owl, expanding its range westward and northward in recent decades, takes roosting birds regularly. The long-eared and short-eared owls hunt open habitats where wintering robins may forage, and the eastern screech owl, despite its small size, is capable of capturing adult robins at the upper limit of its prey size range. Ground-based predators pose different challenges depending on the stage of the robin's life cycle. Domestic cats are among the most significant predators of robins in suburban environments, and multiple large-scale studies have attempted to quantify the mortality they impose. A domestic or feral cat operating in suburban habitat may take several birds per week throughout the year, and robins, which forage on the ground and in low shrubs, are disproportionately represented among cat prey. The impact is particularly severe on fledgling birds, which spend their first 1 to 2 weeks out of the nest on or near the ground, capable of short flights but unable to sustain the rapid escape maneuvers that adult birds use. American crows and common ravens raid robin nests regularly, taking both eggs and nestlings. This nest predation pressure has been a significant force shaping robin nesting behavior and nest placement strategies. Robins respond strongly to the presence of crows near their nests, launching vigorous mobbing attacks that involve intense calling, dive bombing, and sometimes physical contact with the intruder. The effectiveness of mobbing against crows is variable. A determined crow can typically withstand the harassment of a single pair of robins long enough to complete a raid, but the presence of multiple neighboring pairs joining the mobbing response can sometimes drive a crow away before it locates the nest. Raccoons are significant nest predators in areas where their populations are dense, which in North America increasingly means suburban and urban environments. A raccoon that locates a robin nest will consume both eggs and nestlings, and its dexterous forepaws allow it to reach into confined spaces that other predators cannot access. Robins respond to the presence of raccoons with the same alarm calls used for other predators, and neighboring birds often join in the mobbing response, though the effectiveness against a large mammal is limited. Snakes, particularly rat snakes and garter snakes in eastern North America, are effective nest predators where they are common, and robins have been observed attacking snakes at the base of nest trees for extended periods, sometimes attracting the attention of additional birds from adjacent territories. Red foxes, striped skunks, and Virginia opossums round out the mammalian predator community that interacts with robins through nest predation. And in the western portions of the range, Steller's jays and western scrub jays play much the same nest predation role that American crows do in the east. The overall rate of nest predation in American robins is high by the standards of temperate songbirds, with studies in various habitats finding that between 40 and 60% of all nesting attempts are lost to predators before the young fledge. This high loss rate is offset by the robin's ability to attempt multiple broods per season, and by the rapid growth rate of the young, which fledge approximately 13 days after hatching. The alarm system of the American robin is one of its most ecologically significant features. When a robin detects a predator, it produces one of several distinct calls that convey different levels of threat and urgency. A slow, thin C call is produced in response to the sudden appearance of a hawk overhead, a call so high-pitched and lacking in tonal cues that it is extremely difficult for a predator to localize, allowing the calling bird to warn others without betraying its own position. A rapid staccato tuck-tuck-tuck call is produced in response to ground predators or near predators that are moving slowly, a call that signals danger but is lower in pitch and easier for other species to detect. A sharp, intense alarm call is used during mobbing, serving both to recruit other birds and to harass the predator through sheer acoustic pressure. The cross-species significance of robin alarm calls has been demonstrated experimentally. Many species of birds, including several that share habitat with robins, but have no close evolutionary relationship to them, respond to robin alarm calls by freezing, hiding, or flying toward cover. Chipmunks, squirrels, and white-tailed deer have been observed responding to robin alarm calls in ways consistent with predator avoidance. The robin thus functions as a kind of sentinel species in the communities it inhabits, and its vocal responses to predators carry information of value to a wide range of other animals. This indirect ecological service is rarely considered in assessments of the robin's role in its community, but it represents a significant and pervasive form of interspecies communication that operates continuously throughout the bird's active hours. Part 5. Family life. The reproductive life of the American robin is structured around speed, efficiency, and repetition. In a world where most nesting attempts end in failure, the robin's strategy is to attempt again and again and again, compressing as many complete breeding cycles as possible into a single warm season. The result is one of the most thoroughly observed and documented nesting sequences of any bird in North America. A clockwork of behavior that plays out each year from late March to early August, across millions of territories from Alaska to Mexico. Nest construction in the American robin is exclusively the work of the female. The male may accompany her to potential nest sites and sing nearby, but he contributes nothing to the physical work of building. This division of labor is characteristic of the species and represents one of its clearest expressions of sexual asymmetry in parental investment. The female selects the site, typically a horizontal branch fork, or the crotch of a tree between 2 and 15 meters, or 6 to 50 feet, above the ground, though ground-level nests have been documented in dense shrubs, and nests at heights exceeding 20 meters have been recorded in large trees. The preference is for sites that are partially sheltered from above by overhanging vegetation and positioned close enough to the trunk or main branches to provide structural support. The nest itself is a sophisticated multi-material structure built in distinct layers. The foundation consists of coarse grass stems, strips of bark, and thin twigs that provide structural integrity and anchor the nest in its support. Above this, the female adds a layer of wet mud, collected from puddles, stream margins, or any moist soil surface, shaped and pressed with her breast and feet into a smooth cup that hardens as it dries into a rigid shell. This mud cup is the characteristic feature of a robin nest, distinguishing it immediately from the nests of related thrushes that lack this element. The outer diameter of a completed nest is typically about 15 to 18 centimeters, or 6 to 7 inches, with an inner cup approximately 10 centimeters, or 4 inches across. The interior of the cup is lined with fine dry grass, hair, and other soft fibrous materials that create a clean, insulating surface for the eggs. The completed nest takes between 2 and 6 days to construct under typical conditions, though the timeline lengthens in cool or rainy weather when mud drying is slower. A female may make hundreds of trips to gather materials, carrying mud in her bill and pressing it into place with rapid lateral movements of her head, shaping the inner cup by rotating her body in place within the structure, using her own breast as a mold. The result is a nest of considerable durability. The hardened mud layer remains structurally sound through rain and wind, and completed nests have been found intact on nest ledges of buildings after 2 or even 3 successive seasons, though robins typically build a new nest for each breeding attempt rather than reusing old structures. The eggs are among the most immediately recognizable objects in North American natural history. A clutch of 3 to 5 eggs, typically 4, each approximately 2.5 centimeters, or about 1 inch in length, of a vivid sky blue color produced by the pigment biliverdin deposited in the eggshell during formation. The color has no markings, no spots or streaks, just the pure flat blue that has given its name to a shade recognized in every hardware store paint chart and color vocabulary list in the English-speaking world. The intensity of the blue varies somewhat between individuals and between clutches, and it fades slightly after laying as the pigment is exposed to light, but the fresh egg is one of the most striking objects in the natural world. Incubation begins after the last egg is laid and is performed almost entirely by the female. She sits on the eggs for roughly 12 to 14 minutes of each 15-minute cycle throughout the day, stepping off the nest briefly to forage before returning. During her absences, the male typically sings from a nearby perch, maintaining his territorial claim and advertising his presence to potential rivals. The incubation period lasts approximately 14 days, varying slightly with temperature. Cooler conditions slow development and may extend incubation by a day or two. The male does not incubate but remains attentive to the nest area, and both sexes respond to nest threats by approaching and calling. Hatching is a prolonged process. The chick uses a temporary egg tooth, a small hardened protuberance on the upper bill that disappears within a few days of hatching, to crack the shell from the inside, a process called pipping that may take up to 24 hours to complete after the first crack appears. All eggs in a clutch typically hatch within a span of 1 to 2 days of each other, and the parents remove the broken shell fragments from the nest immediately, carrying them away and dropping them at a distance from the nest site. This nest sanitation behavior reduces the reflective visibility of white shell interiors that could attract predators, and it is performed with a consistency that suggests strong selective pressure from predation on clutches. Newly hatched American robins are all trishul, born naked, blind, and completely dependent on their parents for warmth and food. They weigh approximately 5 to 6 grams, or a fraction of an ounce, at hatching, and are capable only of lifting their heads and gaping when a parent arrives at the nest rim. The gape response is triggered by the vibration of an arriving parent and is accompanied by an intense visual signal. The interior of the nestling's mouth is a bright yellow-orange, surrounded by the yellowish-white flanges of the gape, creating a powerful target for the parent's food delivery. The chicks grow at a rate that is remarkable even by the standards of altricial songbirds, doubling their weight in the first 3 to 4 days and reaching close to adult body mass within 10 to 12 days. Both parents feed the nestlings, and the division of labor between male and female shifts during the nestling period. The female broods the young for the first few days when they are unable to thermoregulate, keeping them warm by sitting over them, while the male increases his own foraging and brings food to her at the nest. As the chicks grow and develop the insulating capacity to maintain their own body temperature, the female's brooding decreases and both adults forage intensively. Feedings occur approximately every 20 minutes per chick during peak growth periods, with earthworms, caterpillars, and soft invertebrates making up the majority of deliveries. Fledging occurs at approximately 13 days post-hatching, when the young birds leave the nest. At this stage, they are capable of short, weak flights, but cannot sustain the extended aerial maneuvers of adults. The fledglings spend their first 1 to 2 weeks in dense vegetation near the nest site, calling softly for food and being fed by their parents. Within this post-fledging period, the parental division of labor becomes asymmetric again. The male typically takes over primary care of the fledglings, while the female begins constructing a new nest for the next brood of the season. The fledglings themselves gradually disperse as their flight improves, moving further from the nest territory and beginning to practice the foraging skills they will need for independent life. A breeding season for a pair of American robins may contain 2 or 3 complete nesting cycles, each separated from the last by the time required to build a new nest and complete a new incubation period. The window between the departure of fledglings from parental care and the onset of autumn migration may be a matter of only a few weeks, and in successful years a pair may raise as many as 9 or 10 young to fledging, though the majority of these will not survive their first year. Part 6. Social bonds. The American robin presents what might appear to be a contradiction. It is a bird that spends its breeding season in fierce territorial isolation, driving away competitors with sustained singing, direct chases, and on occasion physical fighting. Yet it gathers in winter in roosts of thousands, moves through migration in loose flocks, and maintains a social fabric that is more nuanced and persistent than its reputation as a solitary garden bird would suggest. Understanding the full social world of the American robin means looking carefully at each of these contexts and at the relationships between individuals that develop within them. Territorial behavior in the American robin is among the most conspicuous aspects of its spring and summer life. Males arrive on the breeding ground slightly before females and immediately establish territorial boundaries through song. The robin's song, a fluid series of rising and falling musical phrases typically rendered phonetically as cheerily, cheer up, cheerio, is a complex and individually distinctive vocalization produced from a prominent perch, usually near the top of a tree, in the early morning and again in the late afternoon. Each male's song is slightly different from those of his neighbors, and playback experiments have demonstrated that males respond more intensely to the songs of unfamiliar individuals than to those of established neighbors, suggesting that robins learn to recognize the voices of their immediate neighbors and calibrate their responses accordingly. The phenomenon of neighbor recognition extends beyond mere acoustic identification. Male robins appear to track the movements and activities of their immediate neighbors throughout the breeding season, adjusting the intensity of territorial defense based on the behavior of specific individuals. When a neighbor is actively singing from the boundary between their territories, the focal male increases his own singing output and may move toward the boundary. When the neighbor is absent or foraging quietly in the interior of his own territory, the focal male relaxes his boundary vigilance. This dynamic maintenance of territorial relationships reduces the energetic cost of constant aggressive defense and creates a kind of social stability that benefits all the established males in a neighborhood. Physical territory defense escalates from song to direct confrontation when song alone fails to deter an intruder. Two male robins in dispute will often fly toward each other from opposite ends of the disputed boundary, meeting in the air or on the ground and engaging in a rapid, intense encounter that involves posturing, feather ruffling, and high-pitched calling. Actual physical contact, involving bill jabbing and wing slapping, occurs less frequently than these confrontations might suggest, as most disputes are resolved by one individual retreating before contact is made. Genuine fights, in which both birds make sustained physical contact, are relatively uncommon, but do occur, particularly when a territory holder is confronted by a persistent floater, an unmated male without a territory, who repeatedly probes the boundaries of established territories in search of a gap to fill. The relationship between a mated pair of American robins is defined by proximity, coordination, and a clear and shifting division of reproductive labor. The pair bond is established each breeding season, and while individual birds do frequently return to the same breeding territory in successive years, pair fidelity between specific individuals from one year to the next is inconsistent. Studies using individually banded birds have found that some pairs reunite in successive seasons, while others do not, with the tendency toward reunion influenced by territory quality and the previous season's nesting success. The pair bond is thus better described as a seasonal arrangement than a permanent partnership. Mate feeding, in which the male brings food to the female, occurs during courtship and continues into the early incubation period. This behavior serves multiple functions. It supplements the female's nutritional intake during the energetically demanding period of egg production. It reinforces the pair bond through repeated positive social interaction, and it may function as an honest signal of the male's quality as a provider, allowing the female to assess his foraging ability before committing to a full nesting cycle with him. Female have been observed selectively rejecting food from males, and the quality and quantity of mate feeding early in the season correlates with subsequent nesting success in some studies. Within a brood, sibling relationships among American robin nestlings are shaped primarily by competition for parental deliveries. When a parent arrives at the nest with food, the chicks compete through posture and calling to be the one fed, stretching their necks and waving their heads with an intensity that increases with hunger level. Unlike some bird species in which the largest nestling monopolizes food and the smallest may be underfed to the point of starvation, American robin chicks generally maintain relatively similar rates of growth throughout the nest period, suggesting that parents distribute food with at least some degree of equity. Whether this is an active parental choice or a consequence of the physical mechanics of nest feeding is difficult to disentangle. Siblings that fledge together from the same nest may remain loosely associated during the post-fledging period, calling from nearby perches and sometimes foraging in the same general area while still being fed by their parents. As parental feeding decreases and the young birds begin foraging for themselves, this loose sibling association dissolves and individuals disperse independently. By the time of autumn migration, young birds that hatched from the same nest have typically become functionally independent individuals with no demonstrable tendency to associate with their siblings. The communal winter roost represents the most intense expression of American robin sociality. Roosts form in late autumn as temperatures drop and day length decreases, typically in dense thickets of evergreen trees or shrubs that provide structural shelter against wind and cold. Within the roost, individual birds do not maintain personal space in the way they would during the breeding season. Birds crowd together on branches, sometimes in physical contact with neighbors, sharing body heat in a way that measurably reduces the thermoregulatory costs of cold nights. The density of birds within a large roost is impressive, with multiple birds occupying every suitable branch in thickets covering an area of a few hectares. The social dynamics within a roost extend beyond simple physical proximity. There is evidence that birds use the roost as an information center, with individuals that have foraged successfully on productive fruit patches attracting followers when they depart the roost in the morning. A bird that has identified a large, persistent berry supply will return each morning to the same patch, and over time, its roost mates that observe its consistent directional departure begin to follow, spreading knowledge of food locations through the flock without any direct communication of information. This information center hypothesis has been debated in the ornithological literature for decades, but the evidence from robin roost studies is among the more convincing in support of the idea. Part 8. Human history. The American robin has been in the consciousness of North American peoples for as long as people have lived on this continent. Its visibility, its boldness, its association with seasonal change, and the unmistakable quality of its song have made it a persistent presence in the symbolic and practical lives of the many cultures that have shared the landscape with it. This human-robin relationship is not simply a feature of modern suburbia. It extends back through centuries of indigenous cultural life and forward through European colonization, the formation of new national identities, and the ongoing negotiation between an urbanizing society and the natural world it has never entirely left behind. Among indigenous peoples of eastern North America, the robin appears in the oral traditions, ceremonies, and practical ecological knowledge of many nations. In Ojibwe tradition, the robin carries specific associations with spring renewal and the return of warmth, recognized as one of the first conspicuous signs that the long cold of a northern winter is ending. The red breast of the robin features in Ojibwe stories as a mark earned through specific actions or transformations, framing the bird's appearance as meaningful rather than incidental. The Cherokee, whose range overlapped with the robin across the Appalachian highlands and surrounding lowlands, recognized the robin as a bird of good omen in some narrative traditions, associated with the onset of planting season and the agricultural cycles that structured Cherokee life. These associations were not arbitrary. They reflected accurate ecological observation of a bird whose arrival timing correlated reliably with the soil conditions that made spring planting possible. The Lakota and other Plains nations encountered the American robin primarily as a migratory phenomenon, observing the large flocks that passed through the grasslands and river valleys of the Great Plains each spring and fall. In Plains cultures with strong oral traditions around the movements of animals and the timing of seasonal activities, the robin's migration was integrated into a comprehensive knowledge system that tracked dozens of species and their seasonal relationships to human needs. The broader category of observations that indigenous peoples accumulated over thousands of years about robin behavior, migration timing, and habitat use represents a form of ecological knowledge that predates Western ornithology by millennia. The arrival of European colonists brought a collision of symbolic frameworks. English settlers brought with them a rich cultural and literary tradition around the European robin, a bird so embedded in British folklore, Christmas iconography, and popular sentiment that its name and associations had become nearly archetypal. When these settlers encountered the American robin, the naming impulse was immediate, and the cultural associations followed. The new robin was interpreted through the lens of the old one, a bird of gardens, of threshold spaces between the wild and the domestic, of reliable seasonal appearance, and of song that marked the transition between winter's silence and spring's abundance. The robin's association with spring in American literary culture deepened throughout the 19th century, reaching its fullest expression in the enormous body of poetry and prose produced by writers for whom the first robin of the year had become a metaphor for hope, renewal, and the possibility of new beginnings after periods of hardship. Emily Dickinson wrote of the robin repeatedly, investing it with an almost theological weight as a herald of seasonal transformation. Henry David Thoreau recorded robin arrivals in his journals with a precision that amounted to long-term phenological monitoring, noting dates, weather conditions, and song quality in a body of observations that modern climate researchers have used to document the advancement of spring timing over the past century and a half. The selection of the American robin as the state bird of Connecticut, Michigan, and Wisconsin in the early 20th century reflects the bird's position as a symbol of common ground in a diverse society, a species visible, familiar, and beloved across class, ethnic, and geographic boundaries in a way that rarer or more spectacular species could not be. The robin campaigns in these states, driven largely by schoolchildren's voting programs organized by state naturalist societies and women's clubs, reflect the early 20th century's interest in building civic identity through nature, using a familiar bird as a symbol of shared landscape and shared seasonal experience. The use of the American robin as an indicator species in the early history of environmental concern represents one of its most significant contributions to the human relationship with the natural world. Rachel Carson's Silent Spring, published in 1962, used the collapse of American robin populations in communities where the pesticide DDT was being applied to kill elm beetles as one of its most powerful illustrations of the unintended consequences of chemical pest control. Robins died not from direct DDT application, but from consuming earthworms in treated soil, earthworms that had concentrated DDT to levels many times higher than those applied to the soil surface. The image of suburban lawns strewn with dead robins was viscerally accessible to millions of American readers in a way that more abstract discussions of ecosystem disruption could not be. And the robin's role in Silent Spring helped catalyze the environmental movement that led eventually to the banning of DDT in the United States. What the robin has demonstrated across 4 centuries of intensive human transformation of the North American landscape is an extraordinary capacity for coexistence. It has tracked the spread of European earthworms across the continent's previously worm-free northern forests, turning an ecological disruption to its dietary advantage. It has colonized the suburban landscapes that replaced native forest and grassland across millions of hectares, finding in the lawn tree shrub mosaic of residential neighborhoods a habitat perhaps better suited to its needs than anything that preceded it. It has tolerated levels of human proximity that would exclude most birds from the spaces humans most intensively occupy. And it has done all of this while maintaining enough ecological integrity to serve as a meaningful indicator of environmental health. The American robin remains what it has always been: a thrush, a migrant, a parent, a singer, a forager, a neighbor. It is one of perhaps 10,000 species of bird that currently share the planet with humanity, each one a thread in a fabric that took hundreds of millions of years to weave. The robin's familiarity is not a reason for complacency, but a reason for attention. What is common can become uncommon. What is taken for granted can be taken away. The robin, tilting its head on the lawn, drawing a worm from the earth with the practiced confidence of its lineage, is a reminder of this. It is a bird that has been watching over the changing North American landscape for as long as anyone has been here to notice it. And its continued presence is something worth knowing about, worth protecting, and worth deserving. The end.